Applying our decision rule as always, we can see that the p-value of 0.004 falls into this first condition here. It's less than 0.05, indicating that the test is significant, which means that openness to e-texts changed from the freshman to senior years. So since we know that the test is significant, we'll look back at our means once again, and we can see here that seniors were significantly more open towards e-texts, as they have the higher rating, than were freshmen. So next we'll write these results using APA format. And our written results could look as follows. Students were significantly more open to using e-texts in their senior year as compared to in their freshman year. And then we have T for our t-test with 9 degrees of freedom, which is equal to the number of people total minus 1. We had 10 people in our study, minus 1 is 9. We have a t-value of negative 3.82, which you can see right here in our output. And then we have a p of 0.004, as we saw earlier here. Let's go ahead and spend a few moments on the confidence interval as well. Recall that the confidence interval, if it does not include 0, that means the test is statistically significant. But we already know that the test is significant by using the p-value approach. But if we look at the confidence interval, we can also see, in fact, that 0 is not in this range, as it ranges from negative 3.98 to negative 1.02. So 0 is not in this range, indicating that the test is statistically significant. Next, we'll talk about effect sizes for our test. Now recall that the effect size for the t-test is given by Cohen's d, where once again a small effect size corresponds to a d of 0.20, medium is 0.50, and large is 0.80. We can use the following formula for Cohen's d, where d is equal to the mean difference divided by the standard deviation of the difference. And here in our paired differences table, the mean difference corresponds to this column, where it shows mean, and then the standard deviation of the difference corresponds to this column, where standard deviation is reported. So if we plug these values into the formula, we'll see we have a d of negative 2.5 divided by 2.07, rounding to 2 decimal places. So negative 2.5 over 2.07 is equal to a d of negative 1.21. Now recall that for Cohen's d, we typically just take the absolute value, so we'll report it as a d of 1.21. A d of 1.21 definitely falls into a large effect size using Cohen's standards. So the effect size in this example is definitely large. And a d of 1.21 means that there is a 1.21 standard deviation of a difference between the senior and freshman year means. So the seniors were 1.21 standard deviations higher in terms of their openness to e-texts than were freshmen. This concludes the presentation on the dependent samples t-test in SPSS. Thanks for watching.